Okay, good evening. Okay, so we were expecting to get to O-level results in the class because I thought that on 15 they will be releasing the results. So normally when results are released in science, maths classes, what we have noticed is there is a 10% of a student reduction normally. So when we get results like the students who were expecting to do silence now, silence, okay? Okay, silence. So students who were expecting to do maths or science or who started to do maths or science because of the result that they have got for O levels, maybe most probably the school might not be allowing them to do A level maths in the particular school. So normally there is a 10% reduction of students every time when we get results. So one factor that I want to talk like mainly when we get results, when O-level results are released, I used to talk about like 15 minutes about the O-level results and how you should learn from that and what is the impact that you have to take from O-level results when you are coming to A-levels. Normally, we do that even in the Sinhala medium class, we talk about the results. So first of all, congratulations everyone who got the result that they were expecting. It might be 9 A's, it might be 8 A's, 7 A's, or 6 A's. So that's okay if you got the result that you were expecting and if you got the result that you have worked for. First of all, congratulations and job well done for that one. On the other hand, what I want to emphasize mainly for the students who didn't get the expected result. So when we are talking about the the expected result cannot be compared with others. For example, for one student, 9A passes will be like what he is expecting and that is the result that he want to get. But let's say he's getting 8A passes and because he did literature thinking that he is good in English and he got a B pass or C pass, and then, but he was expecting to have 9A passes, but he got 8A passes and 1B. But in the other hand, for another student who even got 8A passes, he must be very happy because he's the one who exactly know that how he has worked for this exam. So based on the way that you have worked, even though you have got 6A passes, comparatively that might be a good result. Because I saw a status, there is like we are in a stage that we are not sure, like we means I am in a stage that we are not sure how to call a lady who's somewhere around 40 years, whether to say akka or auntie. Okay, so we are having that problem because like to her son, I'm telling Malli, to what should I address him? So like I can't say exactly. So I'll tell you there is a lady like in our there are so many ladies. I mean like in the neighborhood, but this particular lady I'm referring to, and she has a son who did O levels from your age. So because of event that we did, like we had this alms giving, දානයක් තිබ්බා අපේ පැත්තේ. So because of that reason, for these organizing purposes, I had that lady's number. And then like I saw her status after O levels, and she has posted her son's O level result, and the caption was like, "Congratulations, Puta! We are really proud about you." So that's where the caption. And then I just look at the result sheet, and to be honest, there was only 2A passes. So that's why I'm telling you the results are comparative to the families and your parents, and for yourself, you can't compare with others. Because I know if I say like 2A passes, and if you are telling that someone can be proud about you for getting 2A passes, we don't know the situation at their house. Maybe that student or that Maldi or that son is the first one who at least got a pass for a O-level subject in that entire family. Must be, can be. So that's why I'm telling you, you don't have to compare your result. But like after this one, I'll tell you what are the things that positives that we have to take from the O-level result, and what are the things that we should not take from the, especially this overconfidence, that we should not take from the A-level results. So normally when O-level results are released, I even talk about my O-level results. So I got 9A passes, but I think I'm the only one in the country that who were not happy and who was like worried after getting, even though after getting 9A passes for O levels. The reason is I had another target. Like I used to be a brainy kid back in school. When I was in grade 10, I think I have shared this story. I was in grade 10, like I used to be the class first since grade 6, but I became the section first. Or what you call this grade first, like for the first time in grade 9. So in the grade 9 last term test, I became the grade first, and then onwards I continue it till grade 13 last term. So when I became the grade first in grade 10 last term, I still remember my mark was the total marks was 873 out of 900. So that was an average of 97. And the student who was grade second, section grade second, he got 827. So the difference between grade first, like my mark, and the grade second's mark was like 46. But normally the difference between a class first and class second is even like something like varies from 5 marks, 10 marks, 20 marks, a maximum of like 30 marks. But the gap that I had with the grade second was 46 marks. So then only I realized, okay, this is not my potential. I can do something more. So inside my school, like I'm the grade first, there's nothing else that I can do more than that. But when we are going to the O-level exam, I was planning to take an island rank. I wanted to become, I want to come in the top 10 in the O-level exam. But normally in the O-level exam, we don't get ranks. But in our times, like even we didn't get the ranks, but the first 10 students in the entire island were called to the president's house, and laptops were given, and a scholarship from People's Bank were given that time when Mahinda was the president. I think even now they are doing that, but they haven't published it. So I had that target. So now my target is not become the class first, not become the grade first, to become the become like to come inside the first top 10 in the island. So that was my plan. And then I wrote the grade 11 even exam. And in the grade 11 last term test, it's Western Provincial exam. And the average was something around 96 something. And my friends, like when they go for classes, because I didn't go for classes in O-levels, I only went to a Sinhala class and English class. English class I went because I went since grade 6. Alu හැමෝම ගියා රාතල් එකට යන්න තියෙන class එක. That was the English class. And I went to the Sinhala class because there was something that we had to learn in Sinhala. No? In O-level Sinhala, ටිකක් තියෙනවනේ සන්ධි විභක්ති පොඩි case ටිකක් තියෙනවනේ. There are some issues, so we had to learn. Vichara ඔහොම තියෙනවා. So I went to Sinhala class. So like I didn't have proper connections with other school students. So my friends who used to go to other classes, they came to me and told me like you can even become the island first because your average is, and it was a Western Province paper. Your average was 96 something, and the grade first from Royal, he's even 93, and Visaka, he's from she's having average of 94. So they used to give me this all details, so that even increased my confidence that I can do this. And I wrote the exam, and the results came in evening, and I got 9A passes. So I know that I'm getting 9A passes. That is quite obvious. And even we didn't have a laptop or computer, so my Punchi had a laptop, like Punchi's son had, and he's the one who checked the results and called me and told, okay, you are 9As. So I just told, I know that. Because I know that, like, I'm supposed to get it. No, I deserve it. No, after doing all this work, how can I get like 8A passes and 1B pass? That is not possible. Because I even didn't do English literature because I don't want to risk even getting an A for that one. So I did drama and Natya Harankala, drama and theatre. And I didn't even do ICT because I didn't want to take that risk. And I did health. කොහෙටවත් නැති subject එකක්. සෞඛ්‍ය කියලා තියෙන්නේ. So I did health. So I'm pretty sure that I'm getting 9A passes, and then he told me, and then I told, okay, I know that. So I was expecting next day to like there was one of these the one from the previous batch who became Island 7th from our school, and I before doing O-levels, I just asked him like, what is the procedure after coming into top 10? How are they informing you? So he told you like I got a call from school, and then the school informed me to go to the president's house, and then there's a ceremony in this school. So next day I was expecting to get this call. So I was expecting every time when I get a call, I'm expecting it's either from the president's house or from the school, informing me, okay, that you have to go to the president's house. But like several calls came asking for the results, how was the results, and that call didn't come. And then in the evening, like I was still expecting, I had that hope because I wrote the paper like very well, and I was expecting the call. And then I thought, okay, maybe they haven't finalized this, so next day I'll be getting the call. So when I was watching news in ITN that day evening, then I only saw that they announced all the top 10 winners, and the ceremony has happened in the morning. So then it was like a heartbreak. Like I got shocked because I was expecting to come somehow within the first 10. But that is how life goes. But then when I did A levels, I was not expecting a rank. Even though I got a rank, I didn't expect for that rank, because I by now I know if I expect to a rank and if I keep that hope high, even though we have to keep the targets and all these dreams high. That is true. But if we have high hopes and if we won't be able to achieve it, it's like really disappointing. So that's why like what I when I was doing A levels, I was not thinking about island rank at all, but the class teachers and school teachers were expecting me, and they knew that I will get a good rank, and I did A levels and got a 3 A passes and got a good rank, because I didn't have any expectation in that case. So that was my whole story. And there's another interesting story, but I didn't tell that to anyone. Is what I expect, what I think that I couldn't. So that is the only reason that I think that I couldn't come into the top 10. Is normally like when we were doing the paper, every time like I help others, like even in the MCQ paper, like every MCQ when I keep it here, the one who's behind me, he's looking from. That's why I help that. I'll help to others. There's no harm to me. My result won't like go down when I'm helping others. Where are the vede? But I just do it. And I had to have this habit in history. So in history, we had to mark 10 places in the Sri Lankan map, and 8 places in the world map. So the map gave us 18 marks. Mandana, thank you. We got 18 marks for the map in history. 10 Sri Lankan locations and 8 from world location. So when I was doing O levels, I was like I was very familiar with the Sri Lankan map with all these old names, Kadamba Nadi, with all the names and cities. I was like very familiar. So what I do normally when I'm doing the history second paper, I mark all the papers and all the places in the map, and I send the map to the one who's behind. And the map goes around not around the country, around the class, and like by the time that we have to give papers, the map is with me. So even being like, I'll summarize the story because I don't want to give this as excuse. Even in O levels, I did that, but the only thing is the map didn't come in O levels. So that is the only difference. Like when after like I attached all the papers and I was just looking through this paper and I realized that something is missing. And then I just realized, okay, the map is not there. And then I was looking, and there was one guy, he is now in Canada, Ranusha Dharmaratna, who he was like sitting right in front of the invigilator, but the invigilator was not there. He was like roaming around. And he was looking at me and telling that he has my map. So the map has gone there, but there's no way that he can come. He can't come and he can't come and just walk and give me the map and go. Then both of us has to say like 5 years to write the A-level exam after the suspension. So then I just asked him to keep that with him, like not to attach that map. Then he has 2 maps now. So like keep that in. That is how life goes. So I didn't expect that, because I thought that even though that happens, like so my history is out of 91 marks. So I'm pretty sure out of 9, I'm getting the A pass out of 91. That is, I'm pretty sure like out of 91, I think there must be around 87, no 89. But still, when you divide it by 9, the average is around like 1 mark will be reduced. So I thought that somehow I can end up in the top 10. So that didn't happen. So that's why I told you I might be the only person in the country who got even 9 A passes, good 9 A passes, but even worried because I didn't get the rank that I was expecting. And then we had this scholarship program from Dialogue. They had a scholarship program for the first 25 students, for the top 25 students in O-level exam. So I got a letter mentioning about the scholarship exam. Now I know that I'm in the top 25. Okay, so I just wanted to go there and check what was my exact place. And when I was going there, I was like a bit late. Bit late means on time, but the others has come earlier. So like 10 students were sitting in this way. So there were 10 places and there's no one 11. So I was the 12th. So that's how close I ended up. Like the 10 were sitting in here. There was 10 places. So that means no 11 place. And then 12 chair was empty, vacated. That was my chair. My name has been written. So then only I got to know that my rank was 12. So that is my O-level story. So just to mention, because every time when we get results for O-levels, I just talk about the story. But sweet memories, as I have told you before, that was the best period in my entire school life, grade 10 and 11. So sorry for say that you have passed the best period of your school life. It's grade 10 and 11, because the syllabus is not that complex and you get marks and you have good friends, like especially the friends that are coming from grade 6. But when you go for A levels, the friends split into different streams, and Some change the mediums, and some just go for private universities without doing A levels. And even the most thing, when you're doing math subjects, math science, the syllabuses are even complex. In O levels, it was like shape. You can do it somehow when you, at least when you study 2 3 days before the term test, you can still manage to get average around 70 plus. Things was okay. But now, so that's why I'm telling you, the grade 10 and 11 was your best time in your life. So the main factor that I'm talking is the students who couldn't get the result that they were expecting. So I'm not justifying if you couldn't get a result because something that you couldn't do. If you are telling me, sir, I could have taken a good result. At least if I studied 1 month before the O-level exam, 2 months before the O-level exam, that you know. If the O-levels is starting next week, did you study from start studying today onwards? Or like you know actually what you have done. But what I want to say is, imagine, not imagine, think about your parents' emotions when you were expressing, when you were telling your results to them. Okay. Now what I want you to do, think about your parents' emotions when you were telling the results to them. If they were really happy, like I told you, the results are comparable. You can't compare. So if you are telling me, sir, I got only 4A passes, that is okay if your parents were even happy about that. If your parents are telling, like, I didn't really expect you to get even 4A passes. So if your parents were happy, you have made your parents happy. But if you can remember that your parents were worried because of your result, and that is what you have to cover up from your A-level exam. Because the parents, the needs and the expectations are different. There are some parents, even though you have taken 8A passes and 1B, if there is a student who's like living like in front of your house, who got 9A passes, then that is the problem most of the parents are worrying about. Like he got 9A passes, so there are problems. But what I want to say, if your parents were genuinely happy about your result, then you have done a good job. And then those students have another chance to make your parents really happy, and that's your A-level exam. And for the students who couldn't make their parents happy because the O-level results that they got is less, and make sure even those students, you got another chance to make your parents happy. Because there are only three instances, what I believe, that you can make your parents proud when talking about academics. The first exam is the grade 5 scholarship exam, which we have done. The second one is the ordinary level exam or the O-level exam. And the third one is the A-level exam. Because mark my word, even though you go to the university and you get a first class, your parents are not that much aware about what is this. Like they are educated, like nowadays when talking about your parents are educated than our parents. Because when our parents, like in that generation, there was only state universities and educated, the parents who have done degrees are really less. If I talk about the 40, like in our class, we had 45 students. So altogether 90 parents. I'm pretty sure out of that 90 students, the students who pursue a degree must be less than even 10. But your parents are not like that. So when we become parents, even the rate is high. Because like in our generation, like everyone do a degree. That is simple. So what I want to say is, like when you go to university and even though you take a first class, so in universities you are given a class according to the way that you have performed. First class, second class, there's no any third class. So it's first class, second class, and second class there are second uppers and second lower. So that is the class of your degree. So even though you take a first class, your parents are not that much aware. They don't know about that properly to celebrate that. Because at the end, 95% of the university undergraduates, they pass out as engineers or whatever the degree they're doing. So that in that case, like your parents will be happy in general. When they come to a convocation, they will be seeing that you are passing out as an engineer, passing out as a physicist, passing out as a chemist or like a mathematician or like a software engineer, then they will be happy. But mainly when talking about academics, there are 3 instances. So everyone here got that last instance to make your parents happy. So that is what you can do and that is what you should do. So students who make your parents who made your parents proud from your O-level results, that is really good. I won't be asking any of the students what is your O-level result, what is your O-level result. But if you want to share your O-level result with me, you can just talk, you can come to me and you can talk to me. So I got 9A passes. So if you're having a low result, let's say you're having C4 maths and science, and then you are having a doubt whether you can do maths for A levels, or maybe your school is not allowing, because there was a student who came to me yesterday and talked to me, and she got A for science but C for maths. So her school is not allowing her to do maths because the minimum result that school requires is A and B. But that is legally wrong, because if the student has passed the A-level exam, he or she is suitable to do any stream in her or his own school. The school can't say that we can't allow you to do maths because you got a C pass. That is wrong. Because let's think about the student. The student wants to do maths. And because she got a C pass, and now her school is not allowing she to do maths. So what can she do? And if because the result is really low, then she can't even go to another school. So where can that student do A levels, go for a school? So that is wrong. Okay, even you can talk with your school. If you are a school, there's no any rule that you have to take A or B for maths. Those are just virtual rules made by own schools in order to take the best students for maths and bio classes. But if you want to do, first come and talk with me. So this is my result. I got a C for maths. I got a C for science. Will I be able to do this? Then I'll tell you, will you be able to do this? But I have seen students who have got a average O-level result, but got a good A-level result. And I have seen more students who have got a great O-level result, but an average A-level result. Average A-level result. There are so many students who get 9A passes and end up with 1B, 2 Cs, 3 Cs, 3S passes, and even fail in the A-level exam. Meanwhile, there are even students who get 3A passes, 3B passes, and 3C passes. And then when it comes to A-levels, they are performing really well because they have learned a mistake there. They have learned their mistake there, and they are not repeating it here. So that is the thing that we should not take from your O-level result. If you got 9A passes, good, hats off, congratulations, keep that away. Don't bring that mindset, overconfident mindset for A-levels. If you have the mindset, so we did 9 subjects. So if I did 9 subjects in 1 week, doing 3 subjects for me is a piece of cake. If you think in that way, I'll make sure the content of your entire all 9 subjects is even less than the content you got in physics. Clear? The content of the all 9 subjects is even less than comparing to the content of physics. So that is that complex and the amount is huge. So if you are thinking you were able to do 9 subjects in 2 weeks or 1 month and you got a good result, and now you are expecting, okay, that means for 3 subjects, 1 week is enough. You should have realized that by now because we already did the exam. Okay, because you did the exam in the same way. You did the exam in the same way. Okay, you did the exam in the same way that you did an exam during your O-levels. එහෙමද කරේ? O-level class එකේ කිව්වහම ආද exam එකක් තියෙනවා කියලා there was a particular way you got ready to, you didn't get ready, You just go to the class and you write the paper, So that is the exact way most of the students wrote the paper 2 weeks back. And now you should realize you can't do that in here. There should be a practice. The thing in A-levels is not the student who is having a good potential. If you have a good potential, you can do this. But the student who is working hard, who has that consistency, will be ending up getting a good result. I'll give you 2 examples. One example, he hasn't done the exam yet. So in my 2026 class, the 2 students, and they are how can I say, they are the students who are every time they are top, they are in the top list. 2 students, 1 student from Nuvareliya, he used to go to O-level classes in Nuvareliya, but now he has come to Colombo, and he has boarded somewhere alone, living alone, and his parents are there, sending him all the money. So he's not going to any school, he's a private candidate. So his O-level result was 2 A's and 5 B's, and the other was C and S. And the two A's, one A was for maths and the other one was for health. So maths A is good, but the A for health is kaatotaranne. The A for health is you can't be a doctor no, when you take A for health. So there's no use of that. So one A is for maths. But now, every time when I put out this top 10 list from the entire class, not only the English medium class, from the single medium both. So normally 400 plus students are writing that paper. So every time he's in the top list. Getting good marks, 87. Last paper it was 87 and 85, 90 plus. He's getting good marks. So when I inquired about his physics and chemistry, he's really doing those two well even. So that's why he learned a lesson. He only got 2A passes. So he told me, so I only got 2A passes. I didn't want to I didn't want to do this like that much. I just went to the exam and wrote it. Maths was anyways okay. And he used to play volleyball. So in the health, there is a volleyball question. So he can easily answer that. And the others, when you can do something, then he has got a pass. So that's what he gave me. And then he told me that I don't want that to happen again in my A levels. So that is his motive. The other student is from St. Thomas's. His A level result was 3A passes, 3B passes, and 3C passes. 3 A's, 3 B's, 3 C's. Nice result, symmetrical result. 3A passes, one was for maths. For science, he got B, and the other two was English, and can't remember, but it was not science. So he is the other student, and he is even the grade first in terms of combined maths in St. Thomas's College. So grade first who has done in combined maths, pretty sure he is even doing the other two subjects really well. So that is how you can change your destiny or the way that the result that you have got for O levels. So at the end, I'm sure that both students will be taking 3A passes for A levels. So think about the student from St. Thomas's. For O levels, he even got 3A passes. But for A levels, he even got 3A passes. The other student, 2A passes for O levels, 3A passes for A levels. But there are so many students who are taking 9A passes for A levels and fail to get even 1A pass from the 3 subjects. There are so many students. Okay, so that is what I want to say. Like, I'll end up this from here. Think about the emotions of your parents when you were telling the results. If they check the results and told you, then you can't see any emotions. Then you should go and ask them, what were my emotions? If you just check the results and then you were telling this result to your parents, just think about their emotions. If they were happy, you have done a good job. Congratulations, everyone who made their parents happy. But if you can remember that they were not happy, everyone here, you got another chance to make them happy. And mark my word, that is the last chance you got to make your parents proud about. Because when you go for university, when you go to a university, when you go for higher studies, your parents won't be able to talk about that much. Because even a student who didn't do these A levels properly, even he goes to a university, a private university, and pursue a degree. And let's say he is even becoming a software engineer. Then your parents can't properly and proudly talk about you that you are an engineer. Because there is another student, even his parents are telling that he is even an engineer. They won't emphasize that he went to a private university. But if you get these A-level results properly, then your parents will be taking the calls to everyone, every relative, every friend, and then talking about your A-level result. My son got 3A passes, 2A passes, 1B. 2A passes, 1B is a really good result in the science stream. So have that motive. Let's start from here. If you got 9A passes, let's keep away. If your parents are supposed to buy you, or if they promised you to buy you something, I don't expect any parent will buy you a vehicle for getting 9A passes. But let's say they are buying you a phone or a watch or a PlayStation or a new pair of sneakers or like anything, get that. Be privileged, take the privileges and keep them away. Keep them away means not the phone away, keep the result away. And then let's start from 0, and the students who didn't get a good result, same way, keep that away. Let's start from 0 and let's get this done. Okay, so last week we did partial fractions, and there are like a considerable number of new students. So what I want them to do is Today is the second day of a lesson and next week, listen. Wait. Okay, so there are a considerable number of new students. What I want them to do, silence. Wait. I didn't ask to do anything, wait. Okay, so what did I like mention? So we started a new lesson last week. Today we will be finishing that lesson and next week we are starting a new lesson. So the initial part, I admit you won't be able to understand that like perfectly, but I'll try my best to do it in the simplest way, reminding the previous theories. So even students who have joined today, they can understand like a certain percentage of what we are doing today. But I'll talk to them at the end of the class and what they are supposed to do. And you don't have to think about the previous lessons or recordings. Like I'll talk about that at the end of the class. Next week, when we are starting a new lesson, everyone here should be able to understand that perfectly. Okay. So new students, you don't have, if you like, just look at your friend's book and just ask them how many pages that they have to keep for this partial fractions lesson. Keep that number of pages and then let's start from here. Okay, and it's okay even though you don't understand anything today. I'll talk to you at the end of the class. Okay, so here we have done and I have given you to do homework up to question number 31. So I have given homework up to question number 31. Okay. Okay, silence. Now look at this. Let's do question number 33, silence. So let's do question number 33. It's 3x. Silence. Over x minus 1 squared, x plus 2. So everyone, even a newcomer, like even though you like you couldn't understand this, you have to write down the things that we are doing today. I'll be checking it. So we need to split this into partial fractions. Okay, now silence. Okay, can you be silence? Okay, so what did I explain last week? I told you this part is what we consider as the recurring factor. So if we are getting a factor like x minus 1 squared, x minus 1 cube, we call it as a recurring factor. So this is a recurring factor. So when we have a recurring factor, when we are splitting this into partial fractions, whatever the degree of the denominator is, we have to consider the numerator as a constant. So here I told you the degrees. Here the degree is 1. So the numerator should be a 0 degree polynomial, which is a constant. Here the degree is 1. The numerator should be a 0 degree polynomial, which is a constant. But in this case, here it's okay. The degree is 1, but here it's a constant. That is okay. But the only thing here, you can see the degree is 2. So normally when the degree is 2, what we have to put as the numerator is a first degree polynomial, but since this is a recurring factor, so now it is clear this is a recurring factor part. This is a recurring factor part. So when it is a recurring factor part, whatever the degree of the denominator is, we have to take a constant. We have to take a constant as the numerator. So that is the main thing about recurring factors. The main thing about recurring factors. And now when you, the simplification is the same. When you multiply by the denominator x minus 1 squared, x plus 2 and x minus 4, when you multiply by this, you get 3x is equal to a times x minus 1, x plus 2 and x minus 4, and b times x minus 1 squared cancel off, x plus 2 and x minus 4, plus c times x minus 1 squared into x minus 4, and d times I'm getting x minus 1 squared into x plus 2. X minus 1 squared into x plus 2. Okay. So then you can easily find values by substituting you can find this ABC and d by substituting values. So substitute x equals 1, minus 2, minus 4 and get the 3 values and then find the remaining one. Okay, do this alone. So this one, question number 33. I ask you to do till question number 31. Okay, do this. And find the values a, b, c, d. Find the values a, b, c, d. For the ones who didn't get the tute, I'll give it. Okay, so here, first substitute the values. So you can substitute x equals 1 here. So here you can substitute x equals 1. So when it is x equals 1, here it's 3. And I told you, you don't have to write the terms that become 0. This becomes 0, this becomes 0, and even this becomes 0. Only this is remaining. So b into 1 plus 2 into 1 minus 4. So when you simplify, it's b into 3 into minus 3. 3 cancel off. So what is b? Then when you divide by minus 3, it's minus 1 over 3. So when you divide b, it's minus 1 over 3. It's minus 1 over 3. And then substitute x equals minus 2. First substitute and then check the others. When you substitute x equals minus 2, so here it's 3 into minus 2. Here it's 3 into minus 2. So this becomes 0. You don't have to write it. This becomes 0 and even this becomes 0. Only this is remaining. C into minus 2 minus 1 squared. Minus 2 minus 1 squared into minus 2 minus 4. Minus 2 minus 4. Okay, then I have 3 into minus 2 is minus 6 is equal to c into minus 2 minus 1 is minus 3 squared into minus 6. So here it's clear, minus 6 cancel off. Minus 6 cancel off, and I got this is 1 is equal to c into minus 3 squared is 9, which means c is equal to 1 over 9. So even though you're a newcomer, just for now, just look at the board and copy this. With time, you will realize what we are doing here, what is substituting values and all. For now, just write it, and I'll talk to you at the end of the class. Okay, there's another value that we can substitute, that is x equals 4. Okay, then substitute x equals 4. So when you substitute x equals 4, it's okay, 3 into 4 is equal to this becomes 0, this becomes 0, and even this becomes 0. Only this is remaining. D into 4 minus 1 squared, 4 plus 2. So this is 12 into d into 3 squared, I into 6. So you can simplify this and get the final answer. Okay, 6 cancel off and this cancel off, it's 2. So d is equal to 9 over 2, because 3 square is equal to 9. 3 square is equal to 9. So d is equal to 2 over 9. Okay, so we have substituted all the possible values. We have substituted all the possible values. You can substitute kara. And then I told you, after substituting, you can go with comparing coefficients. Now you can compare the coefficient of x cube. Now what I'm going to do is, I'm going to compare the coefficient of x cube. We now look at this and check the places that where you are getting x squared. X squared kohen hamme nikel balannu. Sorry, x cube. X cube, you get 1x cube when you multiply x into x into x. I think x cube back, you know. So what is the coefficient here? It's a. Clear? So you get 1x cube when you multiply x into x into x. So here it's the coefficient is a. From here you don't get any x cubes. Here it's clear, here we got x squared, and x squared into x gives you x cube. X squared into x gives you x cube. And this one, same thing, here we got x squared into x gives you another x cube. So there are 3 places that we get x cube. there are three places that we get x cube. One is a, the coefficient. The other coefficient is c, and the last coefficient is d, which means the coefficient of x cube can be written as a plus c plus d, which is equal to 0. Why does it become 0? Because there's no any x cube here. There's no any x cube here. So what is a? That is what we are supposed to find. What is c? C is 1 over 9. D is 2 over 9. So 1 over 9 plus 2 over 9 gives 3 over 9. And then you get the answer that a is equal to minus 1 over 3. So we can take three values by substituting the values, and by comparing coefficients, you can find a. When you compare the coefficients. Okay, then write the final answer. Substitute a, b, c, and d. So what is the final answer? Antimuttare, you can write in this way. 3x over x minus 1 squared, x plus 2, into x minus 4, into x minus 4. This is equal to what is a? A is minus 1 over 3 times x minus 1. What is b? B is minus 1 over 3 times x minus 1 squared. What is c? C is 1 over 9 x plus 2, and what is d? It's 2 over 9. So then you can write the final answer in this way. Clear? You can write the final answer in this way. Okay, so that is question number 33. Okay, complete the work, then I'll give another question. So when you can substitute values, substitute the values and get the answers, and then go for a comparing coefficient. Okay, after completing this, do this one. 2x plus 1 over, silence, x minus 1 squared, x squared plus 1. Okay. Split partial fractions of this one. 2x plus 1 over x minus 1 squared, x squared plus 1. 2x plus 1 over x minus 1 squared and x squared plus 1. Okay, do this. Silence. Do it alone. Silence. You can't talk, I can't repeat this. When I ask you to do something that you need to do, be quiet and do it. Try it at least. Okay, so what is the first step here? The first step here is we got a recurring factor. So when it is a recurring factor, it's a over x minus 1 and b over x minus 1 squared. So that is a recurring factor part, no? But the next one is what is in the denominator? It's x squared plus 1. So we have to make sure this, whatever the degrees, whatever the denominator's degree is, the numerator should be a constant that is only valid to this recurring factor part. That is not valid to this one. Because that, like this, these two becomes a and b. So that is only valid to this part. Okay, this one is a normal one. The degree is 2, the denominator's degree is 2. So when the denominator's degree is 2, what should be the degree of the numerator? It should be 1. So in this case, it's something like cx plus d. It's something like cx plus d. You can't put c there. Because if you can only put c if it is a part of this recurring factor. Clear? So this the denominator's degree is not considered when put in the numerator's degree. That is only to this recurring factor part. That is only to this recurring factor part. Again, මේක අර recurring fact එකේ කෙනෙක් නෙමෙයි. It's a separate one. Okay, the simplification will be the normal way. So I'll help here, x minus 1 squared, x squared plus 1. Okay, when you multiply, it's 2x plus 1. 2x plus 1 is equal to a into x minus 1, x squared plus 1, b into x squared plus 1, cx plus d into x minus 1 square. So there's only one value that you can substitute. There's only one value that you can substitute, that is x equals 1. Only one value. So when it is x equals 1, this is 2 plus 1 is equal, this becomes 0, that becomes 0, here is the only remaining one, b into 1 plus 1. I get 3 is equal to b into 2. So there's only one value that you can find by substituting values. It's equal to, b is equal to 3 over 2. Okay. Now what I want to do, everyone, even though you are a newcomer or not, you can do this. Expand this. So just do this. Expand this and separate the x cube terms, x squared terms, x terms and the constant. Everyone do that. Because we are done with substituting values. So I need even the newcomers do this. So you can do this using your O-level maths knowledge. Simplify this and separate the x cube terms, x squared terms, x terms and the constants. So everyone do that. Then let's talk about the simplification. Everyone do that. Simplify the brackets, take out the brackets and separate all the x cube terms, x squared terms, x terms and the constants. Okay, so when you simplify, what do you have? It's a into, okay, this is x cube plus x minus x squared minus 1. This is bx squared plus b. Okay, first expand this, cx plus d into expand this. So this you know, x squared minus 2x plus 1. So do it, like even though you are a newcomer, try to do at least one thing that you can do. Okay, you don't have to copy paste the entire board even though you are a newcomer. There are certain things that you can do those things. Okay, so now when you simplify, it's ax cube, ax minus ax squared minus a plus bx squared plus b. When you multiply, this is cx cube minus 2cx squared plus cx. So it's basically you have to multiply the cx by each of these three, a normal simplification that you know, no? And then this by the other three. So then I have dx squared minus 2dx plus d. And now separate the x cube terms. So when you consider the x cube, it's a plus c. So only 2x cube. Take the x squared terms, minus a plus b minus 2c and plus d times x squared. And then take the x terms, a, who else we got, plus c minus 2d x. I'll take the constant, it's minus a plus b and plus d. So when you take the constant, it's minus a plus b plus d. Okay, now we are comparing the coefficients. So this is the first thing that we have done in polynomials day 1. Comparing coefficients. And now what can you do? You can compare the coefficients. No? So now what can you do? You can compare the coefficients. So here compare the coefficients. There's no any. We are comparing with this one. We make a miss karande pa. So we are comparing with 2x plus 1. So what is equal we consider is 2x plus 1 is equal. Okay. Okay. So there are no any x cube terms. No x cube means the coefficient is 0. So when you take x cube, now write the 4 equations. Write the 4 equations when you take x cube. A plus c is equal to 0. When you take x squared, minus a plus b minus 2c plus d, it's equal to even 0 because there are no any x squared terms. When you take the x term, it's a plus c minus 2d is equal to what is the coefficient of x? It's 2. And finally, when you take the constant, you got minus a plus b plus d, it's equal to 1. It's equal to 1. So this is 4. Okay. Look at these 4 equations and you can easily find a way that how you can simplify this. Look at all the equations. So first properly simplify this. Amulim make a hurry simplify karaganda. Separate the x cube, x squared, x and constant, and then you have to make them equal. We call it as comparing coefficients or equating coefficients. X cube, the coefficient is a plus c, no any x cube, so a plus c is equal to 0. Okay, that way. I'll give you 2-3 minutes. Simplify this and get the values of a, b, c, and d. Simplify and get the values of a, b, c, and d. Look at the 4 equations and you can see a simplification. Okay, so there is a easy simplification here. Is look at this. You have that a plus c is equal to 0. And then again, you are having that a plus c here, no? A plus c is equal to 0 and you are having that a plus c is equal to, is even here. So when you substitute to the third one from the first one, it's a plus c minus 2d is equal to 2, which means a plus c is equal to 0. Because in the first one, they have given that a plus c is equal to 0. And then minus 2d is equal to 2. So d is equal to minus 1. Okay, so we got the value of b and then I got d equals minus 1. Then you can find the other two. Okay, find the other two quickly. Find the other two. Using this, you can find a, and using this, you can find c. Okay, find the other two. And write the final answer. Get the final answer. Okay, other two, I need you to do alone. Okay, so when you have b and d, you can find a using the fourth one. Minus a plus b, b is 3 over 2. And d is minus 1 is equal to 1. So when you simplify this, I'm going to take a here and 1 here. So when you take 1 here, 3 minus 1 is equal to a. Because 1 becomes minus 1. 3 minus, okay, this is equal to, so a is equal to 3 minus 4 divided by 2. So a is equal to minus half. So I got b, I got d, and then I got a. And then easily you can say that c is equal to minus a. Using the first one, you can easily say, you can easily find what is c. Minus half plus c is equal to 0, then c is equal to half. Clear? So I have taken all the 4, a, b, c, and d. And then you can write the final set of partial fractions. 2x plus 1 over x minus 1 squared, x squared plus 1 is equal to a. What is a? I is minus half. Minus 1 over 2 times x minus 1. What is b? 3 over 2 times x minus 1 squared, and cx plus d. Cx. Okay, c. Where c? C is equal to half. half x plus d, and d is equal to minus 1. Clear? So cx plus d and d is minus 1. Can here you can't directly take these two down. I mentioned this even last week. In this one you can't directly take this half down. First you have to take the common denominator and then only you can take 2 down. May make it kelimma mehema meya pallehata ganna bෑ because it's only here. No? Here there's no any divided by 2. So first take the common denominator and then you can take this 2 down. And then you can take this 2 down. Okay, then what is the final answer? Partial fractions of 2x plus 1 over x minus 1 squared and x squared plus 1. This is equal to minus 1 over 2 times x minus 1 plus 3 over 2 times x minus 1 squared. And when you take 2 out, 2 down, x minus 2 divided by 2 times x squared plus 1. Divided by 2 times x squared plus 1. Clear? Okay, complete the work. Let's do the next set of partial fractions. Silence, silence. Wait till others complete. So I have given time till others complete. Silence. I don't have to repeat this much. This is not a that big class. I don't have to repeat this again and again to remain silent. Don't show that typical class behaviors in here, okay? So I have given time till others to complete this. You can see still students are right in this. That's why I'm giving time. So don't talk. Don't be selfish. So I'll give a proper 2 minutes to drink water, and if you want to talk something, you can talk in that time. In 2027 classes, I don't have to repeat this from the beginning, these things. Have that simple discipline from day one. And you know, some students haven't even completed this, but still they are making sure to talk with the others. Don't show you this O-level class behaviors or any other behaviors in this class, okay? I don't know in other classes whether the tutors are allowing and okay when you are talking. So I'm not that type. I'm not a tutor who don't react at all. So when there is in every class there is a normal there is a normal noise, and if that noise exceeds a particular decibel unit, I only react. I'm not that type. Okay, I need the silence throughout the class. Nothing karanna bෑ. You won't understand these complex, these theories and all, if there's no any focus and attention. Okay, so have that simple discipline. Still you can see students are right in this. So why can't you just remain silent? Okay, write the main topic, the next main topic. Try this: separating special rational functions. Separating special rational functions. Separating special rational functions into partial fractions. Separating special rational functions into partial fractions. Okay. Okay, now this is the thing. So I told you how, tell me, how do we categorize these rational functions as normal rational functions and special rational functions based on the denominator, based on the degree of the denominator and the numerator. If the denominator's degree is greater than the, sorry, if the denominator's degree is greater than the numerator's degree, we call it as a normal one. That's like a proper fraction. If it is a proper fraction, the denominator is larger than the numerator. So those are proper rational functions or normal rational functions. But if the degree of the denominator is less than the numerator's degree, or when they are equal, they can be equal. Okay, so when the denominator's degree is less than or equal to the numerator's degree, we term them as special rational functions. So if I take example, this one we got x squared plus 1 divided by x minus 1 and x plus 1. Okay, so here it's clear. What is the degree of the denominator? Tell me, what is the degree of the denominator? What is the degree? Tell me. Yeah, 1. This is 1, but you are getting x squared term, so the degree is 2. The degree is 2. So what is the degree even in the numerator? That is even 2. So both the denominators are equal. Both the denominators are equal. So here what you have to do, when you have to split this into partial fractions, okay, listen. Okay. What you have to do is, do it in the normal way. Just repeat the normal way. So write the two denominators, x minus 1 and x plus 1. Here the degree is 1. So here the degree is degree 0. It's a constant. Put a. And here the degree is 1. So put a constant. So what we have to do is the same thing. Same one, the previous one. Okay, the same one you have to do. But there is one more thing that you have to do. So here the degree is 2 and here the degree is 2. So what is the difference of the 2 degrees? What is the difference of the 2 degrees? It's 0. Okay, what is the additional one that you have to do here? The difference of the 2 degrees is 0. You have to put the general polynomial with a degree 0. So the difference is 0. So you have to put a general polynomial with a degree 0 in front of this partial fraction. So we know what is the general polynomial of degree 0. It's a constant. So it's a constant. So what you have to do here, you have to put a constant in front of this partial fraction. So that is the only additional step. So why did I put a constant? Because the degree here should be 0. So what is the additional step? We have to put a general polynomial of a degree that is equivalent to the difference of the degrees. That is equivalent to the difference of the degrees as the to the beginning part of these partial fractions. So that is the only thing that we have to do. So now let's say you have in x cube minus 2 and divided by x minus 1 and x minus 2. Okay, now it is clear. Here the degree is 2. Here the degree is 2. And here the degree is 3. Here the degree is 2 and here the degree is 3. So when the degree is 2, so what is the difference of the degrees? That's 1. So what is the polynomial? Now tell me what is the polynomial you have to put in front of this? What is the polynomial? It's the first degree polynomial. What is the first degree polynomial? Ax plus b. So you have to put this ax plus b in front. And then the remaining one will be the same. It's c over x minus 1. And d over x minus 2. So normally what we get is up to this one. But let's say, for example, you are having something like x to the power 5 plus x squared minus 7 divided by x squared plus 1 into x minus 2. Okay, now tell me, what is the, this side, tell me, what is the degree of the denominator? What is the degree of the denominator? It's 3. X squared into x, it's 3. Okay, this side, tell me, yeah, what is the degree of the numerator? There you go. When I ask you a question, you don't have any energy to say. When I ask you to talk, you have like so much of energy. Tell me, what is the degree here? It's 5. The degree is 5. So what is the degrees difference? It's the difference is 2. So when the degree difference is 2, what is the polynomial? Tell me what is the polynomial that you have to put here? It's ax squared bx plus c. Here you should be put in a second degree polynomial. Here the degree is 1 and here the degree is 2. Clear? The remaining will be the same. Okay, look at this. Silence. The remaining will be same. So if you take x squared plus 1 as the common denominator, sorry, as the denominator after c, you should put dx plus e. Dx plus e. And if you put x minus 2, what should you put as the numerator? It's f. So you don't get this much of terms. Maximum that you get is this one. There you have to put a x plus b. But in case, if the difference is 2, you should put a second degree polynomial here. Okay, hands up if you understood this one. Okay. You know why? What did I ask? Black and sorry, blue and green shirts. You know what did I ask? Why did you like raise your hands? Taman sa tedi kosa karangin pulang kat ya tusan you. You knew that, no? Okay. Okay. Do write in this way. Write in this way. When the denominator of the when the degree of the denominator, when the degree of the denominator is less than or equal, is less than and equal to the degree of the numerator, the degree of the numerator, the rational function is termed as a, write in a black pen, special rational function is termed as a special rational function. Is termed as a special rational function. Okay, next slide. When we have to separate, a special rational function into partial fractions, a special rational function into partial fractions, the same steps should be followed. The same steps should be followed. The same steps should be followed. Write this in a red pen. Write this in red pen. In addition to the previous steps, in addition to the previous steps, we have to include a general polynomial, or we have to include a polynomial. We have to include a polynomial with a degree with a degree that is equal to the difference of the degrees that is equal to the difference of the degrees that is equal to the difference of the degrees of the numerator and the denominator of the numerator and the denominator. The numerator and the denominator. Okay. So the following steps that we have to follow the same steps. But additionally, we have to include a polynomial with a degree that is equal to the difference of the degrees of the numerator and the denominator. Okay, write these three examples. So when you are writing this, just write the rational function and write this one, the partial fractions as you understood it. As you understood it. Then no ganno denga. Method can't tolerate too much. That's that row. If I notice you're talking again, I'll be taking. So this is one in. I'm not running a daycare center. If I see that row talking again, the entire row will be taken in front. Okay. Okay. Now let's see example in the tute question number 2. Separate the following rational functions into partial fractions. And I'll do the first one. Okay, so what we have as the first one, it's x squared plus 2 divided by x minus 1 and x plus 1. So it's clear the 2 degrees are equal. 2 degrees are equal, so the difference of the degree is 0. That means I need to put this 0 degree polynomial a constant. So put that polynomial and start, and then I got b over x minus 1 and c over x plus 1. Clear? And the simplification will be the same. Okay, so there's nothing new in the simplification. That is the same thing. Okay, by now even newcomers should understand like what we are doing here. You can do something rather than like entirely copying the board. Try to do this at least the simplification. So I multiply by this one. It's x squared plus 2 is equal to a times x minus 1 and x plus 1. B times x plus 1 and c times x minus 1. So when you can substitute the values and then think about the remaining thing. What a value substitute karanna puluwan na, first think about that one. Write what you can use, you can write when you substitute values. Lazy maker. So that's the easiest one. So what I do here is I substitute x equals 1. So when you substitute x equals 1, it's 1 plus 2. This becomes 0, this becomes 0, only this is remaining, b into 1 plus 1. So 3 is equal to b into 2, so b is equal to 3 over 2, clear? So when you can substitute values, substitute and then think about the remaining constants. Then put x equals minus 1. Put x equals minus 1. When it is x equals minus 1 squared plus 2 is equal, this becomes 0, this becomes 0, c into minus 1. So here it's 1 plus 2 is equal to 3 into minus, c into minus 2. So c is equal minus 3 over 2. So I get c is equal minus 3 over 2. Okay, now tell me, so the values that you can substitute, that you have substituted, no, x equals 1 and minus 1, that is okay. Tell me what is the easiest way that you can find a? Easiest way. Easiest way. When you compare which coefficient? when you compare x squared, can you see there's only one place that you get x squared? මෙන්න මේකේ එක තැනක විතර you like what x squared හම්බෙන්නේ. Only one place. Here there's no any x squared. Here there's no any x squared. It's only one place. So you can easily write the value of a by comparing the coefficient of x squared. Here it's clear there's only one x squared and here it's 1. Means a is equal to 1. I get a is equal to 1. Clear? Okay. Then you can write the final answer. X squared plus 2 over x minus 1 and x plus 1 is equal to what is a? A is 1. What is b? 3 over 2. 3 over 2 times x minus 1 minus 3 over 2 times x plus 1. So I get 3 over 2 times x plus 1 and minus 3 over 2 times x plus 1. Okay. Hands up who understood this one? Understood. Okay, now I want you to do, mark these questions. Question number 1, 2, 4, and 6. Wait, 5, not 6. Do question number 1, 2, 4, and 5. Okay, do it. 1, 2, 4, and 5. You silence, do it alone. And if there's anything unclear, you can ask me. So based on this, even newcomers try to do the next one. Question number 2 that you can do. Give a try. Do the things alone. If there's anything unclear, you can ask me. And you don't have to underline the intermediate. Like when you get the answers of A, B, C, you don't have to underline those. Just underline the final answer because I'm just underlining it to I have squared it to highlight it to show you that that is the answer. But you don't have to underline those answers. Okay, so I'll do the second one. We have 2x squared minus 1 divided by x minus 2 and x minus 3. Divided by x minus 2 and x minus 3. So when you divide by this, it's the degree difference is 0. So we have to put a constant here. A b over x minus 2 and c over x minus 3. So the simplification is the same as before. Multiply by the denominator x minus 2 and x minus 3. So when you multiply, it's 2x squared minus 1 is equal to a times x minus 2, x minus 3. B times x minus 3 and c into x minus 2. So first substitute the values and get the answers that you can get easily. When you substitute x equals 2, it's 2 into 2 squared minus 1 is equal to, this becomes 0, this becomes 0, b into 2 minus 3. So here it's 2 into 4 minus 1, b into minus 1, it's 8 minus 1 is equal to minus b. So 7 is equal to minus b. So I get b is equal to minus 7. You get minus 7. Okay. So b is equal to minus 7. You don't have to underline these values. You don't have to underline these values. I'm just like putting this in this way to highlight it so you can see it clearly. Okay, what is the next one? Put x equals 3. Put x equals 3 when it is x equals 3. 2 into 3 squared. Minus 1 is equal to, this becomes 0. This becomes 0. Then this is only remaining c into 1. Then you get that c is equal to 17. You get c is equal to 17. Silence to the back. And after getting those two values, what did I do here? Even previously, I told you in the right hand side, there's only one x squared term. You only get x squared when you multiply this x by this x, because there's no any x squared here, no any x squared here. So when you compare the coefficient of x squared, here it's a, here it's a, and in the left hand side, the coefficient of x squared is 2. So a becomes a is equal to 2. Clear? And then you can write your final answer. What is your final answer? The partial fractions. 2x squared minus 1 over x minus 2, x minus 3. This is equal to a is equal to 2. B is equal to minus 7. So minus 7 over x minus 2. And C is equal to plus 17. 17 over x minus 3. Okay, hands up who got this answer. 2 minus 7 and plus 17. Good. The question number 4. X cube minus 3 over x into x plus 1. Question number 4. X cube minus 3 over x into x plus 1. So here, the degree difference is 1, not 0. Here the degree difference is 1. Here it's 2 the degree. And here the degree is 3. So the degree difference is 1. And then you have ax plus b. So what we have to keep is ax plus b. Plus c over x plus d over x plus 1. D over x plus 1. Clear? Okay, multiply by x into x plus 1. And here you got x cube minus 3 is equal to ax plus b into x plus 1, and with c who's remaining it's x plus 1, with d who's remaining it's x. So first do first things do it first. First things first, and then substitute x equals 0 and minus 1. So you can at least find two values. So when you put x equals 0, it's 0 minus 3. This becomes 0, this becomes 0, only this is remaining c into. So it's minus 3 is equal to c, and c, yeah, so minus 3, c is equal to minus 3. So I get one value, the c is equal to minus 3. Then put x equals minus 1. Then put x equals minus 1. So when it is x equals minus 1, 1 cube minus 3 is equal, this is 0, even this is 0, d into minus 1. 1 minus 3 is equal to minus d. So minus d is equal to minus 2. So I get d is equal to 2. So okay, now look at this. After getting these two values, now it is clear. There's no any value that you can substitute. No. The values that we can substitute, it's gone. So here we have to compare coefficients. So when you are comparing coefficients, what I have here, look at this. It's ax plus b. So I'll write it here. So it's much clear. So what I have here, it's ax plus b into x squared plus x. No. Okay, now look at this. Look at this. Look at the board. So I need the next one, everyone do it properly. Here what I got, okay, look at the board, look at the board. It's minus 1 cube, good. It's minus 1 cube, which is minus 1. So it's minus 4. So d is equal to 4, good. Okay, so here, now what I got here is ax plus b into x squared plus x. No. Now when you look at this, is it clear? There's only one place that you get x cube. There's only one place, no? You get x cube. The only place that you get x cube is ax into x squared. So what is the coefficient there? The coefficient of x cube here, like when you consider x cube, the coefficient a It's a, because a x into x squared. So here, what is the coefficient of x cube? It is 1. So a is equal to 1. And now when you consider the next one, now look at this x squared. Now look at this closely. There are two places that where you have x squared. So there are no any x squared here. Okay, mehe කොහෙවත් x squared නැහැ. There are two places where you have x squared. One is this bx squared easy, and the other one is ax into x. So when you look at x squared, there are two places that you can find x squared. One is b into x squared. The other one is ax into x squared. So if you consider the coefficient of x squared, here we got ax into x. So here the coefficient is a, and here the coefficient is ba plus b. That's even equal to it's 0 because there's no any x squared. Clear? Did you understand? Look at this again. Two places that we got x squared. One is ax into x. The other one is b into x squared. So what is the coefficient? It's a plus b. No any x squared here, so it's 0. So a is equal to 1 and then b is equal to minus 1. Clear? So you can find those two values based on equating coefficients or comparing coefficients. So I'll write the final answer here itself. So you get the final answer. A is equal to 1. So it's x minus 1. C is equal to minus 3 over x. And D is equal to plus 4 over x plus 1. So you can split this rational function into partial fractions. X minus 1 minus 3 over x plus 4 over x plus 1. Okay, hands up who understood this one, especially this step. Who understood? Okay, then do the next one properly. Question number 5. If you have done it so far, really good. So I need the entire class to do the next one properly. Question number 5. Same thing. Now you have to go in the same method. Okay, now let's see. Question number 5 is, okay, again the difference is 1. So you have to start with ax plus b. Now this one I expect everyone to take the answers except the newcomers. Everyone should take the answers. So it's c over x plus 1 and d over x plus 3. So when you multiply this by x plus 1 and x plus 3, so it's x cube minus 2x plus 1 is equal to ax plus b. So make sure you put the bracket here, okay? If not, it's wrong. X plus 1, x plus 3, and c times x plus 3 and d times x plus 1, okay? So first things first, substitute the values and get the constant that you can find. Easy, x equals minus 1. So when x is equal to minus 1 cube, minus 2 into minus 1 plus 1 is equal to, this becomes 0, the corner 1 becomes 0, it's c into minus 1 plus 3. So minus 1 cube is minus 1 plus 2 plus 1 is equal to c into 2. So this cancel off. Okay, 2c is equal to 2. I get c is equal to 1. And then put x equals minus 3. X equals minus 3. So when x equals minus 3, it's minus 3 cube minus 2 into minus 3 plus 1. Okay, this becomes 0, this becomes 0, only d. So it's minus 3 plus 1. Minus 3 cube is minus 27 plus 6 plus 1 is equal to d into minus 2, no? So here it's minus 20 is equal to minus 2d. So d is equal to 10. You got these answers, C1, D10. Okay. Okay, now I told you, now we are going to do this equating of coefficients. So here it's x squared plus 4x plus 3. First write it. Now it is clear. So here what we have is x squared plus 4x plus 3. Okay, when you are equating the coefficients, one easy thing that the only place that you get x cube is a into x into x squared. Okay, so then when you consider, okay, when you consider x cube, it's a is equal, okay, x cube, a is equal to 1. A is equal to 1. And when you take x squared, look at the places that you get x squared. You don't get any x squared here, no any x squared. So only two places that you get x squared. What are the two places? Okay, look at this. One is ax into 4x. So 4ax squared. Other one is b into x squared. So only two places that you get x squared. You get x squared in two places. A into 4x, sorry, ax into 4x, b into x squared. So what is the coefficient of x squared? It's 4a plus b is equal, what is the coefficient? No any x squared means 0. A is equal to 1, so I get b is equal to minus 4. So you get a is equal to 1 and b is equal to minus 4. Then you can write the partial fractions. X cube minus 2x plus 1 over x plus 1, x plus 3. It's equal to ax plus b. So what is a? A is 1, b, where's b? B is minus 4, x minus 4. What is c? It's 1 over x plus 1. And d, it's 10 over x plus 3. Clear? Okay, hands up who got this answer. This. Okay. Good, complete this. Okay, the other thing that I couldn't mention when we were talking about O-level results. Let's say that let's say you got the chance to, now you're getting a good result and you get the chance to go to another school. Okay, so my opinion is, okay, like if you have the chance to go to another school, take that chance because of one reason. So there's only one reason that I'm emphasize it. So let's say you have got 9 A passes, and when comparing to the school of 9 A passes or 8 A passes, you want to go to another school. So why I'm telling you that if you have the chance, get that chance, is not because like when you go to, let's say a boy is going to Royal, Anand, Nalanda DS, a girl is going to Visakha, Udevi, Sirimabo. So I'm not asking them to, if you get the chance to go, take the chance and go, not because that in those schools, every teacher that you get for all these 3 subjects are perfect, nothing like that. Okay. Because to be honest, like I went to Ananda College when I was doing A levels, but from my end, what I saw, only the combined maths that I got was really good. The other teachers were like average teachers. Like there's nothing like when you go to those schools, you get really good teachers. And even now, because of these transfers and all, and even the teachers that used to be at our time is not there anymore. So like you can't get the 100% help from the teachers. But what I expect is when you go to those schools, now let's say you are in a normal school, you are in a ordinary school, and you were the best student in that school. So when you're doing A levels, and even you are the best student, so you can't judge yourself because all the others surrounding you are less than you. Like the potential of them are really less than you. So then you think the amount of work that you are doing is enough. You think that the amount of work you are doing is enough. So there's no any competition. So when there's no any competition, it's really hard to grow. But when you go to those schools, like we can't expect in every school that, for example, like every student is working really hard. So like even in a free period, they are just working, they are studying and they are working and like solving problems. And during the interval, they are eating from the left side and making solving problems. Not as I'm not mentioning about those environments or those surroundings, but like let's say when you go to those schools, you're having a good competition. So when you're having a good competition, automatically you groom yourself. Okay, so like if you're asking me the question, if someone asks me, say I got 9 A passes, I'm in this school and my father or my mother is trying to put me to this school. If you can take the chance, my opinion is take the chance. But let's say that you are having a clear future at your school. Let's say you are in a normally ordinary good school, and you are pretty sure that you can even apply for the prefectship and you can be the head prefect even one day in that school. So if you have that solid future, if you can see that, you can remain in the same school and do that. Okay, so if you have that future, do that. And but the other end, make sure, like, let's say you are trying to go to another school, but you go, like, you don't get the chance because now, like, it's so competitive. When you do, like, when you don't get 9A passes or minimum of 8A passes, it's really hard to go to another school because the amount of students who take 9A passes has increased a lot. When I got a 9A passes in 2012, there were only like 87 students in our batch who got 9A passes. But I saw this year it was something like 176 students in our school. In Gampa Bandarnak, it was like 225. In Visakha, it was something like 200 plus students who have taken 9A passes. So the amount of students who have taken 9A passes is like equally double. So now the competition is really high. So let's say that you won't be able to go to a good school, but that is even okay. Try to try to get the best result from the school that you are learning currently. Because I'll tell you a story. In the 2024 batch, there was a student, a boy from Lumbini Vidyalaya, Lumbini College. Okay, and he got 8A passes and one C pass. He was for Eastern music, and he wanted to go to Royal Ananda, Nalanda. Like, he came to the class from the beginning. He told me, sir, I applied for Royal Ananda and Nalanda. If I get the chance to go to one of these schools, I'll go. If not, I won't be going to any other school. But he wasn't even called for the interview. In interview because he got 8A passes. So he stayed at Lumbini and he became District 94th. And he is the first one from the history of Lumbini who took 3A passes and go to the Morotu engineering faculty. So that's how our faith and all this destiny works. Okay. So we don't know what happens. Like, let's say if he went to one of those schools, and let's say for sure he'll be taking 3A passes, but that will be ordinary 3A passes. No? But now the 3A passes he got is a legendary 3A passes. The first one from his school in the recent history to take 3A passes in maths and go to University of Moroto and District 94. And now he's a legendary character in the science section in that school. Now I'm pretty sure whatever the motivation program the school will be organizing, he will be a guest in that one. So if you won't get the chance to go to another school, make sure if you are in let's say you are in a good school and there are every year students are going to universities, then you can't be legendary. It's a bit hard, but if you are in a such school that you can be legendary. Okay, so make sure you get the thing properly. You have to do this at whatever the school you are, or if you go to another school or the school you are remaining, that's okay. If you can work hard, you can get a good result. Okay. Okay, now do question number 8 and 11. Do question number 8 and 11. Silence, silence. Silence, silence, do the work alone. I can't repeat. Calling QR. Okay, so here the degree is 2 because when you square this, you got a x squared term. So your degree is 2 here. And here your degree is even 2. So the degree difference is 0. So then you have to put a constant here. And then it's a recurring factor. So when it is a recurring factor, it's b over x minus 1 and c over x minus 1 squared. So when it is a recurring factor, it's b over x minus 1 and c over x minus 1 squared. Okay, now multiply it by this x minus 1 squared. So when you multiply, it's x squared plus 2 is equal to a into x minus 1 squared. Of b into 1x minus 1 is remaining, and then c will be there. Okay. So here there's only one value that you can substitute, that is x equals 1. So when you substitute x equals 1, it is 1 plus 2. So it's 1 plus 2 is equal to, this is 0, and it is c. So c is equal to 3. So there's no any other value that you can substitute. No. So then we have to go with this equating coefficients. So in this case, you can write this in this way: a into x squared minus 2x plus 1, and this is bx minus 1. Okay, now when you look at this, it's clear. There's only one place that you get x squared, that is this ax squared. So when you make x squared, the coefficients, when you compare them, here it's a and here it's 1. So a is equal to 1. A is equal to 1. And now if you move on to x, there are two places that you get x. One place is a into minus 2x, a into minus 2x, and this is bx, clear? This is bx, and so here it's a into minus 2x is minus 2a, and into b into x is plus b. Is equal, there are no any x terms here, it's 0. So minus 2 plus b is equal to 0. I get that b is equal to 2. Clear? Okay, then you can write the partial fractions. X squared plus 2 over x minus 1 squared, it's equal to, you can write this. What is a? A is 1. What is b? B is 2. 1 plus 2 over x minus 1. And what is c? It's 3. 3 over x minus 1 squared. Clear? 1 plus 2 over x minus 1 and 3 over. Okay, silence, x minus 1 squared. Okay, hands up, who got this one? 1, 2, and 3. Got it. Question number 11. X cube minus 7 over x minus 4 squared. X cube minus 7, okay. So even here, the difference is 2. Here, the difference is 1, no? Here, it's a first degree polynomial. Sorry, here it's a second degree polynomial. Here, it's third degree. So the difference is 1. So put ax plus b here. Okay, silence. Put ax plus b here. And then I got c over x minus 4 and d over x minus 4 squared. Multiply by x minus 4 squared. So when you multiply, it's x cube minus 7 is equal to ax plus b into x minus 4 squared, c into x minus 4 and d into x minus 1 4 squared. Okay. So there's only one value that you can substitute, that is x equals 4. So when you substitute, it's x equals 4. Okay. So x equals 4. 4 cube minus 7. This is 0. This is 0. There's no here. No? D is only is equal to D. So I get D is equal to 57. Sorry, D is equal to 57. So when you substitute x equals 4, you get D is equal to 57. Okay. Next one, now we need to compare the coefficients. No? So it's better to expand it at least in this way. Then it is clear. A x plus b. So when you expand this, it's x squared minus 8x plus 16. At least it's better to expand in this way. At least up to this step. C times, or you can write cx minus 4c plus b. Okay. Now you can compare the coefficients, no? So when you compare the easiest one, x cube, only x cube is a, so it's equal to 1. And when you consider x squared, There are two places that you get x squared. One is this one, bx squared, and the other one is 8 is ax into minus 8x. Okay, so there are two places that you get x squared. One is this b into x squared, so it's directly b. What is the other coefficient? Ax into minus 8. So minus 8a is the other coefficient. Is equal, there are no any x square terms here, so it's 0. I is equal to 1, so I get b is equal to 8. Clearly, I got a is equal to 1 and b is equal to 8. And to find c, you can compare any coefficient, so, but I think comparing the constant is much easier. So when you compare the constant, here the only constant is b into 16. So here we have these two constants. So when you write the constant, so here it's the same thing, only a simplification. So when you consider the constant, it's 16b 16b minus 4c plus d. So I have compared the constant 16b minus 4c plus d, and it's equal to minus 7. Okay, what is b is 8. Now simplify minus 4c, but d is 57. 4c I'll take here, 16 into 8 is 128 plus 57 minus 7 is equal to 4c. I get 4c is equal, this is 50, 178. No? Yeah. So C, here it's minus 7. Okay, so minus 7. When you take this to this side, it's plus 7. Okay, so when you add it, it's 64. Yeah, it's 64. So 128 and 60. 192. No? Yeah, I get 100. So C is equal to 192 divided by 4. You can divide it by 4, it's 48. So you get, after simplifying this, we are getting a proper value that C is equal to 48. So C is 48, A is equal to 1, and B is equal to 8. Clear? Okay, then you can write the final answer. So what is the final answer? I'll just write it here. I have taken A is equal to 1, B is equal to 8, x plus 8. Okay, what is C? It's 48 over x minus 4. And what is D? D is 57. 57 over x minus 4 squared. Okay, hands up who got this answer. X plus 8, 48 and 57. You got it. Okay. Then let's do one more. Question number 14. Okay, so here the two degrees are equal, because even the denominator we have a third degree polynomial. So then you have to start with a constant. You have to start with a constant a plus b over x plus 3, c over x minus 1 squared, and d over, sorry, x minus 1, and d over x minus 1 squared. Okay, now multiply by the denominator. So it's x plus 3 and x minus 1 squared. So we got 2x cubed minus 3 equal to a times x plus 3 x minus 1 squared, and with b we got x minus 1 squared. With c it's x plus 3 and 1 x minus 1 will be remaining. And with D, it's x plus 3. With D, it's x plus 3. Clear? Okay, first substitute the values x equals 1. So when you put x equals 1, here it's 2 minus 3. This is 0, 0, 0, only D will be there. D into 1 plus 3. So is minus 1 is equal to D into 4, which means D is equal to 1 minus 1 over 4. And when I put x equals minus 3, the other one, x equals minus 3. So it's 2 into, do the simplification properly, 2 into minus 3 cube minus 3. So here it's 0, 0 and 0 only remaining is b into minus 3 minus 1 squared. So minus 27 b into minus 4 squared. Minus 54 minus 3 is equal to b into 16. Which means I get b is equal to minus 57 over 16. b is equal to minus 57 over 16. Okay, so b is equal to minus 57. Okay, then what we have to do is the same thing. Okay, now compare the coefficients. So when you are comparing coefficients, it's x plus 3, x squared minus 2x plus 1. So easily you can get when you compare x cube, because there's only one x cube. Okay, so there's only one x cube. So when you compare x cube, you get a is equal, what is the coefficient? It's 2. So a is equal to 2. So when I compare the x cube, it's directly a is equal to 2. Okay, that is okay. Okay, now the interesting part is now the next one. Now you have found, you have taken 3 constants and only remaining one is c. So you have the freedom to compare. Now we have compared x cube, no? Either x squared or x or the constant. Okay, now this side tell me, if I have given you the freedom to compare any coefficient, you have already compared x cube. Okay, now tell me what is the other coefficient that you are going to decide. What is the the coefficient that you are going to compare? Just tell me, like, just look at this and like anything that I have given you the freedom. So I have given you the freedom to get the to compare the coefficient of any other term except x cube. It can be x squared, x or constant. What will you be comparing? X squared. Okay, so x squared. Okay, this side. Listen. Okay. So if I give you the freedom to compare x squared, x over the constant, what will you be comparing? X constant. Understood the question? So the question is, I have given you the freedom to compare x squared, x and the constant. So what will you be comparing? X. Okay, so mix answers constant and x squared. This side, tell me, what will you be comparing here? I have given you the freedom to compare x squared, x and the constant. What will you be? Huh? The constant. Okay, so the thing is here. Now look at this. If you are going to compare x squared, first thing you have to find the coefficient of x squared in here, which is 3x squared minus 2, and then you have to multiply it by a. And then you have to find the coefficient of x squared here, and you have to find the coefficient of x squared here. So you have some amount of work. If you go with x, again you have to simplify and get the coefficient of x here, Simplify and get the coefficient of x here. Simplify and get the coefficient of x here and even x. So here it's basically d, no? Dx. No? But if you take the constant, I know I get the constant only when I multiply these last two terms. No? So easily you can take the constant, no? Because we get the constant when you multiply these last two terms. So if you consider the constant, what is the coefficient? It's 3 into a, it's 3a. Here, what is the constant? It's plus 1, no? Because when you square this, you get plus 1. So what is the constant here? It's plus 1. Even here, directly you can say the constant. What is the constant? Minus 3 into c. So when you take the constant, it's easy because the constant is every time the product of last two terms. This one here, the constant is every time the product of last two terms. You have the freedom to take any coefficient, that is okay. But I prefer, in this case, if you can go with the constant, you can easily write the answers because here it's 3a. And you know when you square this, what we got here is x squared minus 2x plus 1. So here it's b into 1 plus b. Here it's minus 3 into c minus 3c, and here it's 3d. Is equal to the constant. What is the constant here? Minus 3. You can now substitute 3 into a is 2. B is minus 57 over 16. 3c. C is what I'm supposed to find. D is minus 1 over 4 is equal to minus 3. So here you can do a small simplification. 3 cancel off, 3 cancel off, 19 remaining, 3 cancel off, 3 cancel off, and 3 cancel off. So I can see a 3 here, I can see a 3 here. In each term there is a 3, so I cancel off that 3. So then the simplification comes up to 2 minus 19 over 16, a minus c minus 1 over 4 is equal. When we cancel 3, it's what is remaining? Minus 1. So I'm taking c to this side and bring minus 1 here, it's plus 1. So your c is equal to 2 plus 1 is 3. So take 16 as the common denominator, it's 48 minus 19 minus 4, which is 28, 23. So it's 23 minus, not 23, 24. Okay. So I get the value that C is equal to 25 over 60. But you have the freedom, I told you, you have the freedom to compare any coefficient. If you are going to compare x squared, that is okay. If, let's say you are going to compare x squared, same answer, same thing. Nah? If you compare x squared, you see what do I get from x squared here? 3x squared minus 2 is plus 1. So here the coefficient is a. And from here, what is the coefficient of x squared? It's b, a plus b. What is the coefficient of x squared? It's c. Even you can take that one. It's equal to, there's no any x squared, it's equal to 0. So a is 2, b is minus 57 over 16 plus c. So even you can get the answer in this way, clear? So c is equal to 57 over 16 minus 2. When you simplify this, you get the same answer, 25 over 60. So you have the freedom to compare or equate any constant. Okay. Then write the final answer. Okay, put here and write the final answers. Okay, take a break and come. It's 5. Come by 6, 5. If you didn't collect your paper last week, the papers have kept outside. You can collect it. Okay, silence. Now start. Okay, silence. Start question number 3 and separate the first two rational functions into partial fractions. Question number 3 means page number, not page number, the main question 3. Separate 1 over silence. Separate over x plus 1, x plus 2 and 5x over x plus 1, x plus 2. Okay, I'll give you like 3-4 minutes, quickly separate these two. Okay, okay, now stop talking. Start question number 3. Do the okay. Start the question number 3. If I talking, I have given a question. Gibarakyan, the Israel Gandavino, then do question number 3. Don't like Rome others. Find the two partial fractions in question number 3. Okay, so now when you split these two rational functions into partial fractions, you are supposed to get these two answers. So now you have to find this. And then if you look at this, the question that they ask in hence, so they have used the word hence. So what is the meaning of hence, not the plural of hen? So hence means, what is the plural of hen? What is the, okay, this hence is not the plural of hen. So what is the actual plural of hen? Chicken. Chicken. Okay. So you better find it. Even I don't know. I can't remember. Okay. So here, so the meaning of hence is that we have to use, okay, now listen. We have to use a result that we have previously shown. So the word that even deduce is the same one. Deduce or hence is an English word. Hence do this. But even in deduce and in maths, both the words deduce and hence means we have to use these two results and get the final result that they are asking. Okay, now what they are asking me to show that this is equal to this. So we have to split this into partial fractions, but they have given it in a way, hence show that this is equal to this. Okay. Now if I ask you, now tell me, if I ask you to separate this into partial fractions, that you can do. A over x plus 1, b over x plus 1 squared, c over x plus 2, d over x plus 2 squared. That you can do. If I ask you to split this into partial fractions, you can do. But they have used this word hence. No. Now what I want you to do is look at these two rational functions. Look at these two rational functions and tell me how can you take this rational function using this one and this one. Like I'm asking you, how can you take this rational function using this one and this one? How can you take this one using these two? When you multiply, you get it, no? You can just look at the denominator. It's clear when you multiply this. So this is what you get. Clear? So when you multiply this, this is what you get. So here it's clear. Here it's clear. 5x plus 7 over x plus 1 into x plus 2 into 1 over x plus 1 and x plus 2. So here they are asking us to separate one. So I told you, you have to think of a way, how can we write this using these two? So it's clear, it's a multiplication. Okay, now what you know this is equal to 2 over x plus 1, 3 over x plus 2. 3 over x plus 2. And what is this? It's 1 over x plus 1 minus 1 over x plus 2. Clear? So what did I do? It's clear. It's clear that I can get this rational function when I multiply these two. And now you can simply multiply. When you multiply the normal multiplication, this multiply by these two, So when you are multiplying two fractions, you know the numerators multiply separately and the denominators multiply separately. That you know when you multiply two fractions. Numerators they whenever multiply whenever, denominators they whenever multiply whenever. So it's 2 into 2 over 1 and it's x plus 1 squared. X plus 1 into x plus 1 it's squared. Minus 2 over x plus 1 into x plus 2. When you multiply these two, plus 3 over x plus 2, x plus 1. And when you multiply the last two, it's minus 3 over x plus 2 square. It's minus 2. So here it's a normal multiplication. You have to multiply a normal bracket simplification. This by this, and this by this, and this by these two. Okay, now these two you can simplify. Minus 2 plus 3 you can simplify. So here I have 5x plus 7 over x plus 1 squared and x plus 2 squared is equal to, okay, here it's, and minus 2 plus 3 is plus 1. It's 2 over x plus 1 squared and plus 1 over x plus 1, x plus 2. And we have minus. Okay, now let's forget about the answer that they have given. Forget about the answer that they're asking us to show that this is equal to this. No? Let's say if they have just asked you to separate this into partial fractions, tell me, can you keep this as a final answer? Can you keep this as a final answer? Can or can't? Hands up if you are telling yes, you can keep this as the final answer. No one. Hands up if you are telling no, you can't keep it as the final answer. What is the reason that you can't keep it as the final answer? What is the reason? It cannot be kept as the final answer. What is the reason? The proper reason? Partial fractions means the simplest format. You have to keep it in the simplest way. But is this a simplest format? No, this is not a simplest format. So here, when you look at this question number 1, it's clear. You can again separate this into partial fractions, which gives you 2 over x plus 1 squared plus 1 over x plus 1 minus 1 over x plus 2 minus 3 over x plus 2 squared. So what we do here is using the two results that we have derived previously, I have splitted this into or separated this into partial fractions using this way. So what we have to do here is think of writing the rational function using the two rational functions that we have already separated into partial fractions. Okay, hands up if this is clear. Okay, write in this way, put a red star mark and write in normal pen. Red star mark and write in normal pen. In these kind of questions, in these kind of questions, in these kind of questions, these kind of questions, we need to write the given rational function. We need to write the given rational function. We need to write the given rational function in terms of the two rational functions. In terms of the two rational functions. In terms of the two rational functions, we have already separated. We have already separated partial fractions. We have already separated partial fractions. Okay. Okay, then write this in terms of these two. Write this in terms of these two and get the final answer. So express this in terms of these two and get the final answer. So always keep in mind when you keep it in terms of, when you are writing it in terms of partial fractions, it should be the simplest format, okay? It should be the simplest format. Okay, now tell me, if I have asked the question, hence separate this one into partial fractions. Okay, I'm asking the question, like separate 5x plus 8 over x plus 1, x plus 2 into partial fractions. Okay, now tell me, what did I tell you? We need to think of a way how we can write it using these two. Okay, now tell me, how can we write this rational function using these two? You can add these two. No? So it's clear you can add these two. When you add these two, same denominator, 5x plus 7 plus 1. So if you can write this in terms of 5x plus 7 over x plus 1, x plus 2 plus 1 over x plus 1, x plus 2. Using the rational functions that we have already splitted into partial fractions, you can express this. This is ideally the second one. Yeah, even here I mistaken that. This is the second one. This is the first one. Okay. Okay, so then you can write the final answer. Hence, it's 2 over x plus 1, 3 over x plus 2, and then I have 1 over x plus 1 minus 1 over x plus 2. So you can get the final answer. 1 plus 2, it's 3, 3 over x plus 1. 3 minus 1 is 2, 2 over x plus 2. So that is how we use hence, using a previous result. Using a previous result. Write this here. So write the question, hence separate 5x plus 8 over x plus 1, x plus 2 into partial fractions. Hence separate 5x plus 8 over x plus 1, x plus 2 into partial fractions. Okay, write this question. Separate 1 over x plus 1, x plus 2 and 2 over x plus 2, x plus 3. Separate 1 over x plus 1, x plus 2 and 2 over x plus 2, x plus 3 into partial fractions. Hence write 3x plus 5 over x plus 1, x plus 2, x plus 3. 3x plus 5 over x plus 1, x plus 2, x plus 3 in terms of partial fractions. Hence write 3x plus 5 over x plus 1, x plus 2, x plus 3 in terms of partial fractions. Okay, you don't have to do this again. Use this result. Only do the second one. This one you can just import the result. So after this one, we'll be doing the last part of partial fractions. That one, even newcomers can understand the last part of partial fractions. So that part, the entire class should understand. Even newcomers, even though you were not in the first day, still you will be able to understand it. Okay, now look at this. You get these two. Now listen, you get these two in this way when you separate it into partial fractions or write in terms of partial fractions, you get these two. Okay. Now what you have to do is look at this. Okay. Listen. Now we have to check, like we have two denominators. I told you the point that we have to cater is like look at the denominator. So like in maths, normally what we do, every mathematical problem you start, initially you can do it in the normal way. But there is, like in out of most of the questions, there is a certain point that you might be stuck and you need a additional way to think about it in order to have this flow in the question. ඕන මැත්ස් ප්‍රශ්නයක පටන් අරගෙන සාමාන්‍ය විදිහට කරගෙන යන්න පුළුවන්. හැබැයි එක තැනක හිර වුණාට පස්සේ එතනින් ඉස්සරහට හිතන්න මොන හරි පොයින්ට් එකක් ඕනේ. There should be a particular point that you are using to think that problem. So what I told you here is that you can think from the denominator. So now look at these two denominators, and these are the two terms that we are supposed to use. Okay, now tell me, how can we get this denominator? How can we get this denominator from these two denominators? How can we get this denominator from these two denominators? Tell me. You don't get when you multiply. When you multiply, you get x plus 1, x plus 2 squared. Okay, so tell me, how can you get this denominator by these two? You have to consider the common denominator, no? You have to consider the common denominator. Okay, now tell me, in fractions, where do you consider the common denominator? Either when you are adding the two factors or when you are subtracting the two fractions. So that is the point that I need you to think. First thing, how can I get this denominator using these two? Then you realize it's the common denominator. It is the common denominator. So where do you consider the common denominators in fractions? It's either addition of the two fractions or the subtraction or the difference of the two fractions. So when you look at this, then you can decide, okay, just add them. Before writing, just add them. So when you add them, you know x plus 3 is missing, it comes here. It becomes x plus 3. X plus 1 is missing here, it goes there. So it's 2x plus 2. So it's clear when you add them, you get this 3x plus 5. So then, how can you get this using these two? Add the first one and the second one. Add these two, the first one and the second one. And see what is the result that you get. So when you add this, it's 1 over x plus 1, ix plus 2, 2 over x plus 2, x plus 3. So when you add them, take this as the common denominator, x plus 1, x plus 2, and x plus 3 as the common denominator. So x plus 3 multiplies by 1, and x plus 1 multiplies by 2, 2 times x plus 1. Clear? Okay. And now it is clear when you simplify it, you get that 1 over x plus 1, x plus 2, plus 2 over x plus 2, x plus 3 is equal. When you simplify, I'll write the answer. It's 3x plus 5. Okay, now you were supposed to separate this right-hand side into partial fractions. So it's clear, it's a common denominator. You consider the common denominator. You consider the common denominator when you add or subtract the two fractions. So I'm again reminding, I told you it's what is that word? Addition or, say it properly. You still I hear that SI. It's not subtraction, I told it. You have been learning the wrong word for like 6 years. It's not subtraction, it's subtraction. So there can't be a second S when I hear that. Subtraction, not subs. Okay. Okay. Somewhere we have to learn the real one. So here from number 1, you can say it's 1 over x plus 1 minus 1 over x plus 2. And from the second one, you get it's 2 over x plus 2 minus 2 over x plus 3. Clear? And we were supposed to split this into partial fractions. And then you have the final answer. I'll just write this here. It's 3x plus 5 over x plus 1, x plus 2, x plus 3. So it's 1 over x plus 1. These two gives you plus 1 over x plus 2 and minus 2 over x plus 3. So we saw that it's the common denominator. We saw that it's the common denominator. And then the common denominator is considered either when we add the two fractions or subtract the two fractions. Okay. Okay, now let's say, okay, wait. We are having, now listen. We are having two rational functions where we have separated into partial fractions. And let's say one is having a denominator, x plus 1 squared. The other one is having x plus 1 squared, x plus 2. Sorry. Okay. So here, now let's say, we have been asked, hence split into partial fractions. And the denominator they have given is x plus 1 cube, x plus 2 cube. So these are the two rational functions that we have splitted. And we are supposed to find this one, which means from these two denominators, tell me, how can we get this denominator? From these two denominators, how can we get this denominator? We have to multiply the two denominators. So when you multiply x plus 1 into x plus 1 squared, x plus 1 cube is x plus 1 cube. Okay, let's say in the rational function that we are supposed to separate into partial fractions, it's x plus 1 squared and x plus 2 squared. X plus 1 squared and x plus 2 squared. Okay, now tell me, if this is the denominator that they have given, how can we get this one? It's the common denominator. So the common denominator, we have to consider either the addition or the subtraction. It's not always it's not the addition. For example, let's say in this case you haven't given 3x plus 5. Instead, like they give something like x plus 3 minus x plus 3, and they give something like 1 over this one. Okay, so they give something like this, 1 minus x. So here we get that in the subtraction. So what I want you to clear things, when you want to get this one out of this, it's the common denominator. So when it's the common denominator, it's either the addition or the subtraction. Clear? Hands up if this part is clear. Not clear? Okay. Okay, right, the last topic. So this one even newcomers should be able to understand. Last topic. Write this rational functions. Silence. Okay. Rational functions with only one recurring factor. Rational functions with only one recurring factor as the denominator. Rational functions with only one recurring factor as the denominator. Okay, now listen properly. The last one, easy part. So this is like the easiest one. I started question number 1 in the last set. We have x plus 2 over x minus 5 squared. Sorry, x minus 1 to the power 5. So what is the topic? Okay, what is the topic? The denominator only consists of one recurring factor. No any other factors. Okay, no any other factors, only one recurring factor. Okay, now tell me, if you separate this into partial fractions in the traditional way or the normal way, what are we supposed to write? What are we supposed to write? Tell me properly, what are we supposed to write? A over x minus 1, b over x minus 1 square, c over, and it goes up to x minus 1 to the power 5. And the final one will be e over x minus 1 to the power 5. But here, what we do is, instead of doing it that way, we use a substitute here. I'm using a substitute. So what is my substitute? I'm taking this denominator, this x minus 1 as t. Now don't ask me, say, why t? Why can't I take m? No, you can take any letter, any English letter. Okay, so I'm taking this denominator as t. Okay, now tell me when x minus 1 is equal to t, x is equal to what? X is equal to t plus 1. Okay. So what did I do? I have taken x minus 1 as the substitute as t. So x becomes t. You don't like? Okay, yeah. Okay, so x is equal to t plus 1. X is equal to t plus 1. And now I'm using that substitute here. So here I got x. X is equal to t plus 1. X is equal to t plus 1. I then use that substitute. X is equal to t plus 1 plus 2 over what is x minus 1? X minus 1 is equal to t. T to the power 5. So when you simplify, t plus 3 over t to the power 5. And now what I do, I divide this separately. So when I divide this separately, I'm getting 1 over t to the power 4 plus 3 over t to the power 5. So what has happened, I have written this in terms of this, but t cannot be in the final answer because t is something that I have brought into the question. So when you substitute t in x minus 1, so what is your answer? 1 over x minus 1 to the power 4, 3 over x minus 1 to the power 5. So in this way, when you use this substitute and you divide this directly, you are getting the partial fractions. But I know in the normal way, if you write this, it's a over x minus 1, b over x minus 1 squared, c over x minus 1 cube, d over x minus 1, I need our answers, x minus 1 to the power 4, and e over x minus 1 to the power 5. Okay, here it's clear. D is equal to 1, E is equal to 3. But you can see in this one, in my final answer, these 3 has been disappeared. No, these 3 have been disappeared. So when someone's disappeared in according to a mathematical way, how, like in maths, how can someone disappear? When it becomes 0. So here D is equal to 1, E is equal to 3. So tell me, what has happened to these A, B, and C? Those have become 0. So if you do this in this way, if you do this in the conventional way, when you multiply by x minus 1 to the power 5, and if you want to find A, B, C, D, you can do that in that way. And then you will be getting the values A, B, C are 0, D is equal to 1, E is equal to 3. So in this method, when you use this, directly what you get here is partial fractions. Clear? Directly what you get here is partial fractions. Then you might tell me, so this method is a bit confusing using the substitute. I'm okay with the conventional method, I'll do that in that way. It's okay, you can do that. Tell me how you're going to do the question number 6. That's how we're going to do. Okay, then even you don't have letters even. 26 capital letters, 26 simple letters, 60 Sinhala letters. How many letters in Tamil? Tamil, how much? How many in the Tamil alphabet? 44. 24. Ille. Okay. Okay, so this is the way, okay, silence. So in this one, so this is this method that we have when we have a recurring factor, silence. Only a recurring factor, silence. only a recurring factor, you can easily use the substitute and directly get the partial fractions. Okay, write in this way. Write in this way. When the rational function is silence, when the rational function only consists with one recurring factor, we can use a substitute. We can use a substitute for the denominator. Substitute for the denominator and replace the numerator and replace the numerator by the new variable. By the new variable. We can substitute the denominator and replace substitute. We can use a substitute for the denominator and replace the numerator by the new variable. Okay, the next line. After simplifying this rational function, we directly get the partial fractions. Okay, do question number 1, 2, and 6. Small thing. Use a substitute to the denominator. Silence. Replace the numerator from that substitute. Silence. Every time after I give a question number 1, 2, and 6. So every time after I give a question, I can't ask you to be silent. Do 1, 2, and 6. So newcomers even do, they should even do the second one and the sixth one alone. Can do. This is something that you can do. Okay, the second one, use a substitute. So when you use a substitute to the denominator, x minus 2 is equal to t. That means x is equal to t plus 2, because we need the x value to substitute to the numerator. That's why I'm taking x. Okay, then this is equal, what is x? X is t plus 2 squared minus 3 over, this is t to the power 7. So then you have to simplify this. When you simplify, it's t squared plus 4t plus 4 minus 3 divided by t to the power 7, t squared 4t plus 1. And then what we have to do, divide this separately. T squared divided by t to the power 7, 4t divided by t7, and 1 over t7. So it's equal to 1 over t to the power 5, 4 over t to the power 6, and 1 over t to the power 7. So you have to keep your answer in terms of x, not in terms of t. You have to keep your answer in terms of x, not in terms of t. 1 over t means x minus 2. Silence. Plus 4 over x minus 2 to the power 6. And 1 over x minus 2 to the power 7. So every time after using a substitute, you have to bring the variable back to x and keep it in terms of x, not in terms of t. Do the last one, question number 6. Okay, same one, use the substitute. So you can use any letter, not only T, any letter. X minus 1, I'll take it as M. So x is equal to m plus 1. So why do I need x? Because this x should be replaced. Okay, so it's 3 times m plus 1 minus 2 over m to the power 2025. 3m plus 3 minus 2. Okay, so it's 3m plus 1 over 2025. When you separately divide it, you get it in this way. So it's when 1m cancel off 3 over m to the power last year, 2024, m to the power 2025. So next year when we update in the tune, what we normally do is we put this as x to the power 2026. So when you bring your sister back in like 5 years, you will see the same problem is 2030. So that is how tunes get updated. Okay, so write so when you bring your son in like 20 years, එතකොට මන් නැහැ හැබැයි ගේන්න එපා. So it's x minus 1 2024 plus 1 over x minus 1 2025. Okay, okay, hands up who got this is 3. No? Okay, hands up who got this answer. Okay, you can get ready to go. Okay, okay, silence. So we had, wait, I need silence. Quickly, I'll do this quickly so you can go by 7:10. I need 5 minutes. Okay, so we had the silence. Okay, we had the main paper one 2 weeks back, and you got the marks last week, and even we had the discussion. So, like this is the only time that I'll be giving separately medals to the English medium class, because I just felt it's a bit unfair for the single medium class, because in the single medium class, the top 10 started somewhere around 87. And even students who got 85 didn't get medals. But in the in the English medium, the top 10 starts from 72. So it's a bit unfair. So what I do here, from here onwards, the exams, the first, second, and third, students in the English medium class will be getting medals separately. But if there's any student who is among the top 10 in both the classes, even that student will get a medal. If not, like it's unfair to the single medium class. No? So you have to be more competitive, okay? Not that you have to wait till in that way, you have to be more competitive. So I'll announce the names who has scored more than 70. And when I say that it's top 10, they have to come to the stage and get the medal. So these 3 students just stand up in the, in the place that you are sitting. Chamjit from Royal College, Amzi Jahamal from DS Senanayaka, Nitesh Tivagaran from Hindu College. Okay, so all 3 has scored 72.14. Okay, give a round of applause. No. Okay, good. So you can see it. So, so top 10 starts from here. Quickly come. Navindu Heshan from Mahanam, 72.85. Is he? No, he is not here. Okay, so then 9th, Yasasni Savindya from Lumbini, 75.71. රත්පුඩිය දෙන්න ඕනේ අපට දාම් පස්සේ වගේ ඕගොල්ලෝ. Then we have silence. Remain silent till I give medals. So she's 9th, Sneha Silva, 75.71. Can't talk. You have to remain silent. If not, I'll be. You have that discipline and that what we call this ethic. When someone is getting awarded, remain silent and just at least You don't have to clap, just remain silent. That is a simple ethic, no? When someone get awarded, remain silent. Isn't it ethic? අමලු ගන්නල නැද්ද? I don't know, like when someone is getting awarded, isn't it an ethic, not a rule? පොඩ්ඩිම දෙයක් නෙමෙයිද ඒක? Someone is getting awarded here, and then they are shouting and they are speaking, and then they are living their own world. It's not a rule, it's a ethic. A basic humanity quality. You guys have to be like totally erased and built from the beginning. මකවල හදන්න ඕනේ කියන්නේ. I don't expect these things. Like come to a 2025 class and see how the 400 students, like 400 plus students stay when we award it. Shit, total shit. Okay, then we have so 10, 9, 8, 7, 7th place, Dunnington Emmanuel from St. Joseph's. Okay, then we have 5th place, Tanusha Pereira, Visaka Vidyalaya, 78.57. Okay, then we have 4th place, Dinul Vinsita from Anand, 80 college, 80 marks. Okay, he's not here. Then 3rd place, we have Basuru from, no surname, Basuru from Thurston, 83.57. Okay, then 2nd place, it's Vinya from Hindu Ladies College, 90.71. Then 1st place, it's Chenuli Imasha from Visaka, 92.86. Okay. So like no අරවගේ වැඩ කරන්න එවනේ මම තරහ කියලා තියාගත්තා නම් ඕ වෙන්නේ හතමානකම් බැනුම් අහන්න නෑ ඊට පස්සේ. හරිද? ඒ වගේ වැඩ කරනවා. it's a small ethic නේ එක තියාගන්න. මම දන්නේ කොහෙන්ද qualities ආවේ කියලා කමන්නේ මේකේ හරි එක පොඩ්ඩක් හදාගන්න වෙන කෙනෙක් ආවදී next time you should be motivated. I'll want to come to the stage and get a medal. Okay. Okay. So next week we are starting the new lesson. පාඩම් පොඩ ආගන්න ෆෝන් එකත් පොඩ්ඩක් බලන ගමන් shape එකේ ආගන්න. වෙන එකක්ද දෙන්න එකලඟ මොකද්ද බලන්න. Okay. Okay, all good. Nah, name rush. Nah, I thought that you two are watching the phone when I got balan. Okay, next week we are starting the new lesson. It's functions. Silence. Okay, it's functions. So newcomers just stay after the class for 5 minutes. I'll talk to them separately. We are starting functions, and what I want to say, they learn the lesson that you from the exam and from O levels is like next. We are having the next main paper somewhere in the late August or early September. So make sure that you get motivated from these things. And next time you need to see your name in that top 10, or at least you have to improve your marks. If you have scored more than 40 for this paper, that means we have done some amount of work at home. But even though you are less than 40, like keep in mind for the next exam, try to get at least more than 50 because that is the average that we have to maintain. If you maintain that average throughout these 2 years, in the final 6 months, we can put some amount of more work and then get this done in flying colors. Okay, so next week it's a new lesson. Bring the tutor. It's in the same tute. Bring the tute. I won't be giving tute. I will be giving tutes for the students who didn't get the tute. Bring the same book and the same tute. Do all the questions in partial fractions. I'll be checking that next week. I told that I'll be checking this week. Not this week. Next week, I'll be checking all the questions. So you have to complete the entire partial fractions, all the questions in the tute. Okay, we are done for today. You can go.